Okay, what I'm going to go through is I'm going to go through a couple examples on how to sketch graphs of exponential functions. Now, a little review on how do you know if you have an exponential function. A lot of students, when I have in my class, are always confusing exponentials with logs when they first get to know it. Well, the key thing for all exponentials have an exponent with a variable, or the variable is the exponent. All right, so an exponential function, when you look at this, you have an equation, you have a base, and the variable, in this case, when we have x, is going to be the exponent. If you don't have a constant base, or if you have another variable here in a variable, it's a pseudo exponential, but not really an exponential in itself. All right. So let's go through here. Now, another thing about exponentials, if your base is greater than 1, okay, greater than 1, what we know is that this right here is going to be an increasing exponential. All right. If your base is less than 1, but greater than 0, all right, what we have is a decreasing exponential. All right, and that's what we got there. So without further ado, let's go through some. Now, there's some key characteristics about all exponential functions. Exponential functions have, all right, a horizontal asymptote and a y-intercept. Horizontal asymptote and a y-intercept. So here we have an exponential function. It has a base, all right? This base is e. We have x plus 2, and so on and so forth. So what we're going to do is graph this. All right, we're going to compare it to our basic graph of an exponential. Now, when you think about the basic graph, just like any transformations, you're going to look at this, and we're going to compare it to the graph of e to the x. All right, e to the x. I'm just going to go y equals e to the x. Now, when you compare it with the graph of e to the x, e to the x by itself has a y-intercept right here. We can do a table, but I'm not going to do a table. I'm just going to actually just graph it. We have a y-intercept right here, all right, at 0, 1. Okay, 0, 1. We also have a horizontal asymptote. I like making that noise when I'm making asymptotes. All right, at y equals 0. Okay, it's a horizontal asymptote. That's why we have y equals 0. E is a base which is greater than 1. Therefore, our exponential graph is going to be increasing like this. And so that is the base exponential graph. Now, from that, we can look at our other exponential graphs or our transformations and see what's happening here. Well, what we have here is that we notice that all our points are being moved, all right, in different places. And that includes our horizontal asymptote. Now, when our horizontal asymptote, since it's horizontal, it moves up or down. Okay. So looking at this, we have negative e to the x plus 2 minus 1. So what is happening? Well, by looking at this, we can see that, all right, let me get a color here. We are going to be moving it to the left 2. So all our points are moving to the left 2. All our values are moving down 1, down 1. We also are reflecting, all right, this negative on the outside is a reflection, all right, over the x-axis. All right, this is over the x-axis. Did I spell that right? All right, x-axis. So what we're going to do is we're going to sketch this graph by doing those transformations. So our horizontal asymptote is going to be reflected over the x-axis. Well, it is x-axis, so it's essentially just going to move down 1. All right, and it's moved to the left 2. Well, it's just a horizontal line, so it doesn't really move anywhere. So essentially, the vertical shift moves the horizontal asymptote. All right, the vertical shift moves the horizontal asymptote. In this case, it's just moving it down 1. So we have this, and I'll just write that like that. And we have our new horizontal asymptote at y equals negative 1. So that's our horizontal asymptote. All right, so that's all of our asymptotes we got here. The next thing we're going to do is we're going to move this, all right, original y-intercept. When we look at the y-intercept, it starts right here. And we're going to move this to the left 2. Left 2. All right. All right, we have that. Now it's going to be reflected over the x-axis. So instead of being here at positive or negative 2, 1, it's now going to be here at negative 2, negative 1. And then we're moving this down 1 as well. All right, so we're going to move this down from where its original point is. So we have this new point right here, all right, of negative 2, negative 2. And then if you look at this graph, it's just a reflection. So it's going to be following this right here. And reflecting over the x-axis, and we have that. Now, one thing is with all exponential graphs, they have a horizontal asymptote, but they also have a y-intercept. And I didn't plot the y-intercept. I probably should make it a little better. So let's find our y-intercept. Now, how do you find a y-intercept? Well, a y-intercept can be found with, like any other function, is that a y-intercept is when x equals 0. So in this case, what we're going to do is we're going to plug in 0 in for x here and find out what our y value is. When we do that, we have negative e to the 0 plus 2, all right, minus 1, which can be simplified to negative e to the squared minus 1. And that's going to be a relatively large number, about e squared, so negative. So probably by about negative 5 or negative 6, somewhere around there. So we have negative 2, 3, 4, 5. So somewhere around here, that's going to be crossing this axis and continue to go down. This exponential function is now decreasing as well. All right, and that's what we see here. Now, with this, in our problem, we're asked to find all the asymptotes. We found our y-intercept, which is located here. All right, we can now find our domain. Well, the domain is what can you plug into exponentials? Well, the domain is, oh, excuse me, right here. Oh, man, sorry about that. Okay, I think we're ready to go. I apologize. All right, the domain is we can plug anything into exponential. So that's going to be all real numbers. Okay, all real numbers. Our range is what are the y values? Well, the y values here for original exponential are all y values greater than 0 because we have a horizontal asymptote. Well, here all the y values are going to be less than, it appears to be negative 1. And so we have that. All right. So that's how we did that problem. Okay. Kind of talked through it. Key thing is know what your original function looks like. And then from there, you can find the horizontal asymptotes. You can find your y-intercept and so on and so forth. So let's try another one. What we have right here is, once again, we have exponential y because we have a base of 2 and an exponent, which is a variable right there. This one is 2 to the x. 2 to the x, since it's base grade, is going to be increasing, so it's going to look very similar to the e to the x that we have right there. Now, what is happening? Well, here we are moving everything up 3. And we have a negative here, which is actually going to be another reflection. But instead of reflecting over the y, we're reflecting, over the x, we're reflecting over the y-axis. All right, the y-axis here. So how do we graph this? Well, let's go through, and I drew a horrible graph. All right, horrible liner here. Okay. If you have graph paper, usually that's a little bit better, but I do not have graph paper. So I'm just going to do this like so. So this is good because you can see how the magic happens. All right. So from here, we are going to be having all of our points. So our horizontal asymptote is going to be reflected over the y-axis. Well, it just flips over here. It's still horizontal. And it's moving up 3. So go 1, 2, 3. And that is actually where our horizontal asymptote will be. It's going to be at y equals 3. Once again, the horizontal asymptote for exponentials is equal to the vertical shift. All right. From here, we're going to take our y-intercept, which originally starts right there, but now is going to be moved up 3. 1, 2, 3. And we have that. It's reflected. Well, reflected over the y. It still stays right there, so we have that. Now, reflection of the y means that instead of having an increasing exponential, we're not going to have a decreasing exponential, like so. I'm going to just draw this graph. I'll make it green. All right, so you can kind of see this a little better. And it's going to go down toward the horizontal asymptote, and then it's going to come up like that, and that is our graph. We can find our y-intercept once again. Let me get blue again. Our y-intercept is, once again, always when x equals 0. So when x equals 0, we plug that in there. I already can see it. It's going to be at 1, 2, 3, 4, 0, 4. But just to verify, all right, y, plug that in there. Well, 2 to the 0 power plus 3, which is going to equal 4. And we verify that the Y is in the correct spot. Let's then find our domain. Well, once again, the domain, I can plug anything into an exponential. And the range is, well, now it's starting, looks like all the Y values are going to be greater than 3, and that's going to be our range. That's it. Easy as pie, right? So, once again, understand exponentials, all right? Understand that the graph of exponentials start low, all right by the horizontal asymptote, but increase really, really fast, and they have this y-intercept, all right, at one of the spots. I like changing the original y-intercept. That helps me figure out where the curve is kind of changing, but that's how I graph exponentials and I teach my class. So I hope this helps you out. We're going to do a couple more tutorials on how to solve these, along with some logs. All right, so good luck and God bless.